Hi learners and welcome back to my channel. In today's video, I'm going to help you ace another topic from maths, which is transposition or transposing method. Now this is a very basic concept but the very strengthening building block of any equation you solve in mathematics. So if you have chapters which deal with equations right from 5th grade, this is something that you need to master because this doesn't leave you until you're learning mathematics, because the key of any equation you will ever solve lies in transposition. This is an easy yet very important concept, and this video is going to be an English explanation in one shot. So now let's get started. So all you have to imagine when you talk about equations is equality, because equation itself you can make out it's somewhat like equality or equal, being equal. So the best example would be a weighing scale. Now this is equal because the level is same. So equations have to be equal. So this is something like 4 is equal to 4, 5 is equal to 5, or a constant x or a variable x will be equal to x only. Now this x can have many values, but all that will only be x. For example, 4 is equal to 4, but 4 is also 3 plus 1. It is 2 plus 2. It is 4 plus 0. So many kinds of values. Now this is also 10 minus 6. 40 minus 36. So it can almost take infinite number of values. So this is how equations actually come out. You have so many different ways in which you can express one values. It's actually infinity. So now with the help of this weighing scale, we will learn how to do the transposition method or how to solve simple equations. Now if I have 4 balls in this and 4 balls in this is equal, or you can in other words say it's in like an equilibrium position. Now if I add one ball here, this is going to go down due to increase in weight. But if I just add another ball here, it's going to balance. Similarly, if I remove 3 balls, this is again going to go down. But here if I remove 3 balls, then again it will attain this equilibrium, or it will become equal. Similarly, in this, if I subtract 1 from this side, if I make it 4 minus 1, this becomes 3, which means on the other side also I need to subtract minus 1 to make it equal. So this is a basic concept. If I want to make this 5, I will add 1 here, but I need to add 1 here as well, or else it will become 5 is equal to 4, which is meaningless. It is not equal to 4. So I add 1 here. Whenever I do something here, I do it here too. Similarly, in fractions, if I have numerator by denominator, if I multiply numerator by 2, I will always multiply the denominator by 2 also. So this is a similar concept. Now let's get into the details. Now, when we solve simple equations, most of the times we find the value of a variable. What we actually find is what is the value of this variable so that this and this part become equal. Now, in an equation, when I have an equation like this, 4x is equal to 7, whatever is on the left side of the equal to sign is known as LHS or left hand side. So you may guess this is RHS or right hand side. So LHS and RHS. Now how do we solve this? So as I had said, we need to find the value of x or solve the equation in x. So we need to find the value of x. So what we have to do is isolate x, make it alone on one side, either LHS or RHS. It is easier and convenient to keep it on the LHS, but it is up to you. So what we have to do is make this x alone on the LHS so that whatever value we get on the RHS, suppose, let me take it as 100 for example. So if whatever value I get on RHS is nothing but equal to x. So you get the value of x. So in other words, we're making x alone on one side. So whatever is on the other side is the value of x. So how do we do this? So in 4 plus x is equal to 7, I want to isolate x. In other words, I want to write this as 0 plus x. If it is 0 plus x, it is nothing but x. So to make it 0, I need to subtract 4. I need to subtract 4 because if I subtract 4, I'm going to get a 0. But as we saw in the weighing scale or equations, whatever I do on the LHS has to be done on the RHS. So I subtract 4 from there as well. So they get cancelled. It forms a 0 here. Plus x is 3. If you substitute 4 plus 3 is 7. So we got value of x equal to 7. Now, you may ask, do we always need to do this on both sides, subtract the same number? You know, we have so many, you can have multiplication, division, etc. So do we have to follow this Hercules process every time? Because this is a very small sum, they may be very big sums. Can we keep on doing the same thing on both sides? Well, the answer is no, because you have a simpler method. So the method is, in 4 plus x is equal to 7, I want to isolate x. So what I will do is keep x on the LHS and take whatever is remaining onto the other side. We are transposing, we are changing the position of everything other than the variable that we want to find the value of. So 4. So how can we transpose it? It is very simple. So 4 here has a positive sign because when there is no sign, it is positive sign. You can also write it as 0 plus 4. So here there is a positive sign. When I transpose this to the other side, I will put an opposite sign. So minus 4. So 4 plus x equal to 7. I will transpose it with an opposite sign. So x equal to 7 minus 4, which is equal to 3. In the other one, what we did was 4 minus 4 plus x equal to 7 minus 4. What I did is same, but I've done it on both sides. So I can directly just change the sign, because when I change the sign, the additive inverse, I get 0. So that's all you have to do. Now let me show you subtraction. The same thing, this time I'll show you using the easier method. So 10 minus x equal to 5. I have to isolate x, but x should have a positive sign. If x should have a positive sign, I can take it to the other side, because we know that when we transpose, the sign changes. So when I take x to the other side, it becomes plus. So I'll write in the next step, 10 equal to 5 plus x. So 10 is equal to 5 plus x. So now I have to isolate x, but this time I'm going to isolate it on the right side. So depending on the sign, you can change your priority of LHS or RHS. So I'll take 5 to the other side. So because here it is positive, it will become 10 minus 5 equal to x, implies x is equal to 5. So that's all. That is very simple. What if x has a positive sign? It becomes much simpler. 15 has a negative sign. When I take it to the other side, it becomes plus 15. So x is equal to 20. Plus 15 implies x equal to 35. You can always check it. 35 minus 15 is 20. Now that was with addition and subtraction. But here, when it is multiplication and division, nothing is being added, nothing is being subtracted. So the sign concept changes a little bit here. Whenever I'm multiplying something, we know that when we multiply a number with its reciprocal, we get 1. So if I say 2, and if I want to bring a 1 here, I just have to multiply with half or 1 by 2. It gets cancelled and brings 1. Because the reason was that when we had done addition subtraction in the previous transposing method, we wanted to get 0 or like the additive identity. Here, I want to get the multiplicative identity of 1. So I will do this method of reciprocal multiplication. So here also there are two methods, but they are kind of similar. Just one is a little bit like a shortcut. The other one is a long conceptual method. So here 6 into x gives me 42. I need to find the value of x. So what will I do here is I want to isolate x, and so I want to bring a 1. I can write this as 1 into x. 1 into x into 6 gives 42. So what I will do here is I want to isolate x. So I'll multiply both sides because I cannot do something just on one side. So I'll write it as 1 by 6 into 6 into x gives 42 into 1 by 6. Because I have multiplied 1 by 6 on both sides, here 6 will get cancelled. And 42 divided by 6 is 7. So x is equal to 7. Now the shortcut method was that when it is something is being multiplied on the LHS, when it goes to the other side, it will become division, because addition became subtraction, subtraction became addition. Here multiplication is going to be division. So x equal to 42 divided by 6. So that's the answer, which is equal to 7. Now we'll move on to division. So in division, x by 7 is equal to 2. So as I said, if something is getting divided here, it will become multiplication on the other side. So x equal to 2 into 7, which is equal to 14. Whereas here, what if x is in the denominator? If x is in the denominator, I have to isolate x so that I get the value. So I will send x to the other side. So if I send x to the other side, I get 30 is equal to 6 into x. And here it's multiplication. So when I bring 6 to the other side, it will come as division, which is equal to 5. X is equal to 5. Another way of writing this itself would be completely reciprocating both sides. So x by 30 is equal to 1 upon 6. So when I send 30 to the other side, it will become multiplication. So x is equal to 30 divided by 6, which is equal to 5. All methods are one and the same, just written in different styles, and yet all are correct. You may see many different types of sums. For example, 4x plus 3 equal to 11. Now, in such conditions, there are multiple operations happening, and that is something that I'm going to deal in the next video of the same topic. So stay tuned. If you like this video, do hit the like button, share it with your friends, and subscribe to the channel for the latest updates. Stay tuned in for the part 2 so that we solve complicated questions, which are actually what come for exams and what you use practically every time, because this video was just a basic. But yes, if you master this session, then you can solve any question based on transposition. Until we meet again, keep learning and take care.